Hello, JT's Physics of Cycling, video number 6 I believe. A lot of good information here in this little book, College Physics. Of course I went through the college physics sequence, university sequence, and then into mechanics and modern physics. But there's a lot of good information in a little book like this if you wanted to get it and study it. But tonight's video, I wanted to talk about the difference between force, energy, and power. And as cyclists and in fact as human beings, I know that you've heard of all of these things. So what are they? What is a force? A force is an application of a body's mass and to accelerate that mass to a certain speed. So let's say we're talking about moving a particle from point A to point B, and the particle is actually at rest. In order for this object to go from being at rest to being in motion, a force has to be applied, and there must be an acceleration. Because if it starts at 0 velocity and moves to whatever velocity, then there has been an acceleration. Okay, so it accelerates from point A to point B. That is force. I mean, it's just the brute quantity, application of force to move an object. But we all understand that. And another way to think about force is weight. Weight. Your force on the surface of the earth, or my body on this floor, is given in pounds. That is a force. It's a static force, but it's still a force, even though I'm not moving. All right. So weight can be given in pounds, or it can be given in newtons in the metric system. But that's force. Basically, a body's weight. Alright, and then that relates to energy in the following way. Energy, or it's the same thing as work. Okay, the expenditure of energy requires us to do work, and it requires that we move this object from point A to point B in a certain amount of time. So energy and work is basically the application of a force through a distance. Okay. So if we move this object from point A to point B, then we've done an amount of work equal to the force that we applied to the object times the distance that we applied the force. Of course, that's interchangeable mathematically with time and things like that. So energy is the amount of force that we apply through a distance. One of the best examples is, say, climbing a hill. So if we apply a force to our system through a distance, then we have expended this much energy. Alright, so finally, the interaction between force and energy, and then power. Power is simply how quickly we can move through this distance. In other words, energy divided by the time it takes us to perform that or to consume that energy. So if we were to climb a hill, we would have to apply a force through a distance. We would have to apply a force, and over the distance would give us some energy. But if we did that at a certain amount of time, and the time was quicker and quicker, then the power was more and more. So power is the energy that we're expending per unit time. So force is simply a weight or the acceleration of a mass, and energy is the acceleration of that mass through a distance. But power is the energy that we've expended per unit time. Now we all know that there is a limit on the human output of power, which is maybe 1,000 watts. Another unit of time or power would be horsepower. But units of force are pounds or newtons. Units of energy are foot-pounds in the English, or joules in the metric. And then power, of course, in English would be horsepower, and units of power in the metric system would be watts. Okay, well, I don't pretend that this is easy, but I plan to get through this series of videos and bring all of this information back to very easily conceptualized ideas on how we as cyclists can perform better. And you don't have to know the math or do the math. But it's simply, I need to go through these videos explaining physics and then bring that back to, you know, an easy application for everybody that rides a bicycle. Incidentally, these are differential equations. The differential of force is energy, and the differential of power, or the differential of energy with respect to time, is power. So the math is complicated. It's differential calculus, and we probably won't get into any of that. But anyway, that's video number 6. Thank you very much.